Welcome back, everybody. This is going to be the final of two parts in my lecture series on solving systems of inequalities. If you haven't watched the first part, please go and watch it now, as it's going to have some skills necessary to follow along in this part. If you have watched that video, let's get started. To solve systems of inequalities, we use graphs to interpret their solutions. So, what do I mean by that? Let's provide a graphical solution to this problem. Just as before, we're going to graph both of these inequalities on the same axis. In order to do that, it might be a little bit easier to write these in slope-intercept form. So in bright green here, I'll write 6y is less than or equal to negative 3x plus 6. Dividing both sides by 6 gives me y is less than or equal to negative 3 over 2x plus 1. And then in dark green here, I'll write y is less than or equal to negative 2x plus 8. Go ahead and pause the video here to see if you can plot those on the same axis on your own. Here's the solution that I found. Y is equal to negative 3 halves x plus 1 is in the bright green, and y is equal to negative 2x plus 8 is in the dark green. Now, I also know that the solution sets for each of these, for the bright green one, it's going to be under that line, since I've got less than or equal to. So that's going to look like this. And for the dark green line, I've also got less than or equal to, so that's going to look like this. And the solution to this system of inequalities is going to be the places where the shaded regions overlap. In this problem, that's going to be this sort of trapezoid region here. Or not quite trapezoid, I suppose. Excuse me. This weird shaped region here would be the solution. It's where the two shaded regions overlap. Let's try another one. Notice that this is a system of nonlinear inequalities, but the process is still the same, just like we saw in the last part. I graph them normally. Be sure to pay attention to whether we have less than or equal to or strictly less than. And then I shade the appropriate regions. The solution will be where they overlap. If you need a hint, let the video play a little bit longer, otherwise pause it and give it a shot on your own. Sorry, but you don't get a hint because I accidentally just drew the whole thing out before pausing or unpausing my recording so that I could record your hint. In this picture, I have drawn x squared plus y squared is less than or equal to 16 in red. If this were an equation, we should recognize this as a circle with center 0 and radius 4. And of course, the circle is the set of all points that are 4 away from its center. But here I'm looking for the set of all points that are less than or equal to 4 away from the center. So it's everything inside the circle. That's one region. The other region is graphed with this blue line here. This is the exponential function y equals 2 to the x. But everything below this line, not including the line, is part of the solution. So the shaded region in purple here is going to be the part of the circle that lies below the blue line. In this video, we saw how to solve systems of inequalities by graphing them. That's going to wrap it up for this lecture series. I'll catch y'all in the next one.